This is Sung, and I'm the Principal and Director of Sky Academy, and I want to be continuing on with the work that we have been doing up until now in relation to probability. And in particular, we're up to the stage where we're dealing with successive outcomes or multi-stage probability, and we're looking at dependent events now. Okay? Now, dependent events are ones where the probability of the second stage depends on what the outcome was the first stage. So a good example of these type of questions are questions involving sampling without replacement. Okay, without replacement. And I'll show you exactly what I mean. And we're going to do a question, one involving with replacement, one involving without replacement, so that you can see the difference. Okay, so let's have a look at this particular question. A carton contains 10 USB sticks, 2 are defective, 3 USB sticks are drawn at random. Find the probability that not more than 1 USB stick is defective if sampling is done with replacement, with sampling done without replacement. Okay, now the first one with replacement isn't going to be dependent. So let me go through that with you really quickly. And I don't want to spend too much time on it, except to say that, except to go through what we've already done before, okay? And it'll serve as a good basis to compare how it's different from something that's done without replacement. So let's have a quick look at this. You've got 10 USB sticks, 2 are defective. We're going to make 3 random selections, okay? So this is choice 1, this is choice 2, and this is choice 3, okay? So we've got, in our first choice, we can either choose a defective or a non-defective USB. In our second choice, we can choose a defective or non-defective, defective or non-defective. And in our third choice, we can choose a defective or non-defective as well. So, your 3 choices here are defective, 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 non-defective, defective, non-defective, defective, defective, non-defective, defective, non-defective, non-defective, non. Does that make sense? They're your possible choices, right? What are the choices, what are the probabilities of choosing a defective in our first choice? Well, defective, there are 2 defective out of 10, so it's going to be 1 out of 5, okay? But to keep it simple, it's 2 out of 10. Non-defective, right? If 2 are defective, 8 are going to be non-defective. So if you've got 2 out of 10 which are defective and 8 out of 10 which are non-defective, when you replace the one that you've chosen, the probabilities are still going to be the same, right? So what you've got is 2 out of 10, 8 out of 10, 2 out of 10, 8 out of 10 for our second choice. For our third choice, it's going to be the same. 2 out of 10, 8 out of 10. 2 out of 10, 8 out of 10. 2 out of 10, 8 out of 10. So the probabilities haven't changed. The probability is still 2 out of 10 and the probability is still 8 out of 10. So the probability of choosing a defective, defective, defective USB 3 times, choosing the defective USB, is going to be 2 out of 10 times 2 out of 10 times 2 out of 10. Does that make sense? The probability of choosing a defective, defective, non-defective will be 2 out of 10, 2 out of 10, and 8 out of 10. Does that make sense? Let's do this one. It'll be 2 out of 10 times 8 out of 10 times 8 out of 10. Got it? So, do you see how choosing 3 random samples with replacement is very familiar, very similar to what we've done before? The probabilities don't change. We just multiply as we go across to find the probability of a multi-stage outcome. And then if we were to add 2 or more of these outcomes together, we would add the probabilities together as well. Got that? When it comes to with replacement, it's going to be slightly different, okay? It's going to be similar up until there, right? Let's leave it up until there, right? Okay, so what is the probability of choosing a defective USB as your first choice? Well, there's 10 USB sticks, 2 are defective, so the probability is 2 out of 10. Yes? Got it? And what's the probability of choosing a non-defective? It's 8 out of 10. Let's go over here. What is the probability of choosing the second one being defective? Well, we've already chosen one of the defective ones, right? So there's only one defective one left, right? We've chosen 1 out of 10, so there's only 9 left to choose from. So what is the probability of choosing a defective as the second choice? Well, it's going to be 1 out of 9, right? See how the probability of this choice was affected by what we chose earlier on? What would be the probability of choosing a non-defective one for the second one? Okay, it would be, what would it be? 8 out of 9. Got it? 1 out of 9 plus 8 out of 9 should give you 9 out of 9. The way that you know if you're right or wrong is these probabilities added up will always give you 1. Okay? 2 out of 10 plus 8 out of 10 gives you 10 out of 10, right? 2 out of 10 plus 8 out of 10 gives you 10 out of 10, right? But what you have here is 1 less than what you had before. So if you had 2 out of 10 before, now it's going to be 1 less than 10, which is 9. Okay, your probability is going to be out of 9 because there's 1 less to choose from. Now, if you choose a non-defective one, the probability is not going to be 1 out of 9 anymore because there's still 2 defective USBs in the box, right? So the chances of the second one being defective are going to be 2 out of 9 because you can choose 2 defective ones from the 9 that are remaining because the first one wasn't defective. The number of non-defective ones, the ones that are okay, that you could choose from, all of a sudden, it's not 8 out of 10, it's 7 out of 9. Does that make sense? Now, if we've chosen one defective one here and another defective one there, and there's only 2 defective ones, is it possible to choose another defective one? No. Alright? So, after you've chosen the 2 defective ones, the only choice left for the third one is that you can choose a non-defective one, and that's going to be a probability of 8 out of 8. Yes? 8 out of 8. Because there's 8 USB sticks left, and there's 8 of them that are non-defective. All of them work. Okay? So that's the probability there. The probability of choosing a second defective one at your third choice is going to be 1 out of 8, and this one's going to be 7 out of 8. Does that make sense? Yep. See how doing questions without replacement is actually a little bit more tricky. You got to think through it a little bit more. Okay, so you just need to think through it a little bit more. Now, if you've chosen one that's non-defective, one that is defective, out of the 10 USBs, right, there'll be 8 left, of which 1 will be defective and 7 will be non-defective. Yes? And then you can also choose defective and non-defective. 2 out of 8, 6 out of 8. Got it? So notice, I just want you to notice that the probabilities aren't going to be as rigid as they were when we did the replacing. Okay? See, it was 2 out of 10, 8 out of 10, 2 out of 10, 8 out of 10. See, it's 2 out of 10 and 8 out of 10 all the way through, right? With the sampling without replacement, when you're not replacing things, every time you pick something, it's going to affect the probabilities of the next choice. Yeah? So you need to be super careful with these sort of questions, right? In which case, your outcomes, let me write your outcomes here. Let me do it in red, okay? Or I'll do it in black, all right? Your probabilities, your possible multi-stage outcomes are going to be defective, defective, non-defective, defective, non-defective, defective, defective, non-defective, 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 defective, defective, non-defective, defective, non-defective, 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 defective, non-defective, non-defective, non-defective. Does that make sense? And the probability for each one will be the probability of this number times the probability of this number times the probability of this number for this outcome. Alright? So for DDN, defective, defective, non-defective, your probability is going to be 2 out of 10 times 1 out of 9 times 8 out of 8. Got it? The probability for the next one, 2 out of 10 times 8 out of 9, 1 out of 8, 2 out of 10, 8 out of 9 times 7 out of 8, etc, etc, etc. Let me finish this off and you can compare it. So I want you to compare the probabilities of each of the multi-stage outcomes with the probability, how you work out, how you calculate the probability for those outcomes with their with replacement counterparts. Okay? Notice how in this case, with the replacement, it's 10 on the bottom, you've got the same number multiplied 3 times, 10 times 10 times 10. And in this case, it's basically 10 times 9 times 8. Each number is going down once. So I want you to familiarize yourself with that. I also want to say that when it comes to sampling without replacement, there are 2 types of examples. The first type of example is without replacement for a small population, which is what we've just done. And there's with sampling without replacement for large populations, right? Which is what we're going to be doing next. Okay? But just be familiar with how to do questions that involve dependent events, right? Yeah. So just be careful of how to do questions involving dependent events, all right? Because they're a little bit trickier than doing the ones that involve independent events. All right. Thank you very much for watching.